what I'm going to talk about today is kind of the very fast-paced developer side of the world than the storage pace, the hardware innovation. Certainly there's things that are going on, but like Ethan was just saying, there's a lot of folks that are contributing to open source software projects that are driving innovation and these tools of mass innovation. So when we start talking about businesses and how they're trying to compete today, a lot of teams are looking to do things, development teams are looking to do things more quickly, to be as fast and agile as possible, to implement polyglot applications, but not only that, but services as well. So there's a number of things that are kind of driving that, what we call the platform disruptors, right? So we talk about Twitter, Airbnb, Facebook, and these companies and the way that they do things. It's to capture a market share. And that's trickling down now from these platform disruptors into the enterprise. So one of those technologies, so show of hands, who has heard of Docker? Okay, good. The next question is, who has actually played with Docker? All right, so this is about right. So we're usually a full house, third of the house. Who's run a Docker container in production? Awesome. That's about how it works. So as we kind of get through these things, this is kind of like your primer on containers in production. So one of the things that we'll talk about here is, in order to run Docker, you got to run a cluster. You can't just run Docker by itself. And we're going to talk a bit about that. And I've got some time. I've got a demo, and I can show you kind of how far this has come even in the last year. So who am I? I'm Chris Ciborowski. I'm the CEO and co-founder of NEBULAWORKS. We're a little consulting company that's based out of Irvine, California, hence the color. I spend a lot of time outside. I'm an ex-Solaris guy, so I was a big iron sun guy back in the day. I had my the leather E10K jacket. If you guys know anybody that had those, the Letterman jacket, I was very proud of that. That I got to manage my E10Ks and then my E20Ks and my F25Ks further down the line. But that kind of dates me. But a lot of the things that we did there, I really feel strongly about. I was a lazy Unix sysadmin, so everything was automated, right? So when I first heard about CF Engine, taking kind of the way back, that was like Valhalla. I mean, it was just beautiful. And between that and automating all of my installs, using Jet and stuff like that was really something special. So now we're kind of taking that same mindset and applying it across the entire supply chain in IT. So that's from development all the way to running apps in production. I'm a Docker organizer, and that's because education first. I mean, this is what we do. I talk a lot and do a lot of evangelizing, but it's out telling folks the story, the history behind the tooling, why it's important, why your developers are using it. If you actually do the same show of hands, you're going to actually see a few more people that have run Docker, not necessarily production because the dev guys aren't doing that, but once we talk about the development pieces, everybody's developers are using it. And just a little bit about me, I'm a super motorsports nut, Formula One and World Endurance Challenge, so not the NASCAR and IndyCar stuff. NEBULAWORKS, that's my company. So what we do, just briefly, because I'm not a Veeam or an EMC or a VMware, and you don't know who we are. So we're a DevOps and cloud consultancy, so we provide advisory consulting services and training on some of these new technologies to help bootstrap our customers' enablement and implement the technologies. We are one of 2 Docker Premier partners. So when we talk about Docker, the Docker guys work directly with us. We do a lot of consulting work for them, for their customers. So when they have needs on integrating these tools that we're talking about in the rest of this presentation, that's the kind of stuff that we do. So it's integration capabilities. CloudBees rounds out kind of part of that pipeline, which we're not going to talk about today. And then GitHub, AWS, HashiCorp. Anybody heard of HashiCorp out of curiosity? Okay, a couple. That's another tool you're going to add to your configuration, management, automation lexicon in your vocabulary, which I probably should have just passed out one of those at the beginning of the presentation. And we live at the intersection of people, process, and tools. So Southern California, big Anchorman fan. Yeah, containers are kind of a big deal. And the reason is that it's allowing developers, and I'm not going to talk about pipelines today, but one of the things that developers have a constant challenge with from IT is being provided an environment for them to work. And an environment not only for them to work, but to get to test-driven development. So what that means is they have an environment that actually looks very, very similar to what's going to run in production and allows them to test locally and then test the unit tests of applications, integration test those applications, and then roll those applications out. So why they like Docker is because it allows the developers to start socializing this development process, share code between the teams in a consistent fashion, and stand up environments that potentially will look just like what they'll look like in production once we start rolling the containers out. So, but in order to run things in production, you can't run one server with a Docker engine on it. If you do, you kind of end up with this. It's a mess, and that's what most people kind of on the path of adoption for containers. You run. You grab an Amazon instance, you install Docker on it, or you've got Docker for Mac running on your laptop, and you compose up a couple containers, and you're like, yes, I have one. That's it. That's exactly what it's going to look like once we get going. And the reality is there's way more stuff to it. And the reality is there's way more stuff to it beyond the stuff that you just need to know for Docker. All of the stuff that's been discussed this morning applies, right? So Docker is this abstraction layer all the way at the top, almost PaaS-like, that gives you this ability to compose and stitch together your components how you like. But everything underneath that, past the developer perspective, still needs to be highly automated. It needs to be consistently managed. You need to be consuming RESTful APIs. But the beauty is that now, because we're putting one more layer of abstraction on top, we don't have to have the developers worrying about what overlay network they're going to be using. They just say, give me a network that these containers are going to talk on. And then we can abstract away the rest of that. So we want to go from this to this. So cargo ships, stacked containers, volatile chemicals in the front, refrigerated containers next to each other where power is. And then we can easily move those containers kind of on and off the ships and orchestrate the workloads that are on the nodes. And this is what the big guys have done, right? So way before Docker became a company, way before they were .cloud, which was a PaaS company, before they iterated into Docker, Google was doing this, right? So C groups and namespaces, the underlying technologies that allow containers to be containers, for us to create these images, which is the concept that Docker had, and instantiate them as processes in a consistent fashion. Those code changes were being done by Google in the Linux kernel in about 2008. And if you even go further back, remember I said I was a Solaris guy, 2005 we were working with zones. So the concepts, and you can even go further back than that and start looking at the mainframe and draw some corollaries there too. So this is kind of what we want to get to. Let's take the Wayback Machine just 1 year, right? So this is the stuff we've been helping customers with. So we have customers actually running containers in production. We have one customer that's going to run on architecture that I'm going to show you in just a second that's running 600 services in containers on 3 nodes, bare metal nodes. And it's a microservice 12-factor application. So it's not lift and shift, old school. This is greenfield type stuff. So Ethan, Snowflake, every platform build was different. Every customer we talked to was different. Some were virtualized, some were bare metal. Some wanted to use Red Hat, some wanted to use Ubuntu. Every decision you could make was different. Some folks wanted to use Arista, some folks wanted to use Cisco. And that creates a challenge, right? How do we, just this piece alone, there's a lot of decision criteria that you need to make and a whole set of best practices around making those decisions. There are at least 7 tools outside of any of the stuff that we've talked about today. No configuration management, no scaffolding tools. We're just talking about the tools that you stitch together in order to run containers and orchestrate them. We're cursed by breaking updates. So how many of you know what a pull request is? Okay. So that's something we're going to need to get familiar with, right? So this is this concept of you notice that something is broken in open source code, open source software, and you do a pull request, make a change, and provide a fix for that software. This is the kind of stuff that we were doing just as of last year. every one of these tools, they don't talk to each other. There's no standards. It's, hey, we listen to the Docker socket and we do these things. And if the Docker socket changes, their tools changes, and I'll explain some of the ramifications of that. And then because we built this kind of point in time Cadillac that's just fantastic and it works great, it's instantly outdated. So the day that you put the stuff in the data center and you stand it up and you've now tested it and you know it works, it's outdated. So the technical debt starts piling up the day you put it in place in production. And that's a major issue because the lock-in piece from a software vendor is one component. But if now you've said, I'm not going to do lock-in and I'm going to build something myself, now you've got to think about how much time and effort it's going to take to actually go back in and redo that if you make a change. So the beauty is, like I said, this stuff is running really, really quickly. So this was just a year ago. We can make some of these design choices today and some move with best practices in even just a year. So let's build one of these. We're gonna do some shopping, and it's interactive. So raise your hand if you've seen any of these logos before. Okay, cool. Y'all should know that one. Come on, you all raised your hand. You know what Docker is, right? We need more caffeine. Let's get some of that. So you need a Docker engine, right? So we need something that's a containerizer. This is what stands up the containers, right? How about that one? Nobody? One person. Swarm, Docker Swarm. Okay, so that's actually, this is the clustering bit. Okay, great. So now we got 2 machines that we can, or 3 machines, actually we should use odd numbers to have quorum. Take 3 of these machines and put them next to each other. Great. But back even a year ago, and even before, way before that, up until the release of 1.12, they didn't do anything sitting next to each other. There were still things that you need to do to stitch these guys together and put a container in place and get to it. How about this one? This is a little more esoteric. If anybody knows this one, I should give you an Amazon $100 gift card.
Docker Data Center?
No, it's not. This is Glider Labs. So they made a little piece of software called Registrator. And what it does is it sits on the Unix socket that Docker spins up, and it waits and listens and says, hey, has there been something that happens? Has there been an event, right? So what it does is it's starting to create an event bus. That feeds into this guy. Anybody know what that is? No? That's console. So that's a HashiCorp tool. It is a KV store. So it's a key value pair store that allows us to do, that's specifically made for service discovery. So it's a KV store that then also has an API, a well-documented API, that we can get and put commands to, and we can receive JSON back, and we can manipulate things that are going on with our containers. So we're starting to build out our bus. How about this one? That's open source software too. That's DNS mask. So this allows us to take one of these nodes running this guy and actually look at myself as my own self as the DNS server, which then in turn turns the console, which knows where DNS by name and port. We can actually look up server records and find out where containers are running.
Except for last Friday.
What's that?
Except for last Friday.
Except for last Friday, exactly. Well, this is all inside the cluster, so we're not going out just yet. So that one, I'm sure some folks know what HA proxy is. This is pretty standard issue stuff. So that is we use for reverse proxy services. So now we're talking about actually getting to the edge. So we got our containers kind of running. HA proxy is now the ability for us to reverse proxy to them and get to those ports. And then this last guy, which is what brings the whole thing together, and we say, when an event happens at the Docker engine, we can launch that container and we can rewrite our HA proxy configuration, hup HA proxy or restart it, and get to that service port across all of the nodes. So just a few things you had to put together a year ago. And if you wanted to change things up, you could say, well, I don't want to use Swarm, I want to use Mesos, right? That's another scheduler. Two-level scheduler has a bunch of different considerations, but in the end, it's another scheduler you can use. Or you could say, I'm an Nginx shop, I'm not an HA proxy shop. That's where our expertise is. Let's use Nginx. All right, so we go get all these tools. And now you've decided this is the kind of stuff that you want to put together. And we start building. All right, so first thing that we have to do is we need to create a certificate authority. So we go spend the time. Who's done this before to create self-signed certs? Okay, all right. So I'll save you the pain. It sucks. It's horrible. And once you do it once, you're going to go, how do I figure out a way to do this better next time? And the better way is not running off to VeriSign and buying a bunch of certificates, especially for something like this, because we're not talking about exterior services that are open to the world. We're just talking about securing connectivity between nodes. It's something completely different. So we set up our certificate authority. Then we get 3 nodes, 3 physical boxes, or three have your vSphere admins spin up 3 Linux VMs, and of the Linux flavor of your choice, distro of your choice. So now we're kind of getting there. And then we go out and we install, and I'm going to show you there's a difference between some of these boxes. These are just normal services. So when we first started doing this, running some services inside of a Docker container is a problem, especially if you're using things like UDP. A year ago wasn't super well documented. That things were performance wasn't there, loss of packets, all sorts of fun stuff. So we run these as external, just normal services, Linux services, right? Console template and console. So we got those pieces. Then we install DNS mask. Right, and this is all, you're sitting there and configuring this stuff. If you're a really sharp admin, you write everything down, then you script it, or then you start putting this stuff into Puppet or Chef or Ansible, the configuration manager of your choice. But once we get that done, then we put HA proxy in place. Then we install the Docker engine, and now we've got a place to run our containers. Right. So up to this point, now but there's nothing. They're not connected. There's nothing talking to each other. It's still just one server with the Docker engine on it, another server with the Docker engine on it, and another server with the Docker engine on it. So then we launch Registrator, right? So this is fantastic. Now we have the ability to talk to the socket, but still nothing there. And then we install a Swarm agent. And once we do that, now we can start building our cluster. And notice I haven't said anything about running a service yet. I mean, this is just to get to the point where you're, no joke. I mean, this is the kind of stuff that keeps keeps admins and site reliability engineers and folks awake at night. Is that you have all these services to monitor too and make sure that they stay up, right? So we're building distributed systems. So if you've done anything in grid computing, this is the magic behind the scenes that allows researchers to just say, hey, here's an algorithm, run it. There's a lot of stuff that goes on. So you launch Swarm, and you've got 1 node. And you launch a Swarm agent, and you've got 2 nodes. And you launch a Swarm agent, and you've got 3 nodes, and voila, now you've got a cluster. So let's just look at a couple of the lines that it takes in order to do that. And it might be hard to see this in the back. But this is just for 2 of the commands to set up to create certs. This command is to launch the Docker Swarm manager. There's actually, in the past, there were 2 containers you needed to run. There was a manager and a Swarm agent. And if I'd put all those containers actually on that last document, it would have been way overwhelming. But you're doing things like saying, hey, where do my certs go? Where do they sit? What ports am I going to listen on? So we need to do port publishing. You better know what hosts you're on as you iterate through each one of these hosts. Or if you're doing a 3-node cluster, no big deal. If you're doing a 5-node cluster, big deal, right? And then how do you automate this stuff? So if you want to automate the installation of all of these things and you're in Amazon, now you're querying the metadata service, or you're using CloudFormations or OpsWorks and trying to figure this stuff out. And that's just to get the bare bones going. And then this is one of the commands to spin up Registrator. Again, a restart always flag. So if we kill the node, if it gets unplugged, or if somebody reboots the VM, that it comes back online afterwards. And we give it a name, and we got to give it the same. Now we're doing volume mappings, which we didn't have to do here, but volume mapping the Docker socket into another container, which isn't really a good thing to do. You want to avoid that if possible, because you're giving this container basically full access to root on the machine. Something to think about, right? So I hope this far I've painted a really scary picture of what it took to run any type of container in production. And like I said, this was about mid last year. And then, configuration files, right? So you got command lines, and you got JSON. You got config files that you need to put together. And if you've never read this kind of stuff before, go get yourself JQ It's a fantastic command line tool, which pretties up JSON. So when JSON doesn't look like this when you get some output out of a REST get. It's a string of text that you're not going to be able to look at on the fly like looking at syslog. And if you were really good at that before, have fun with this. So get used to pipe and get used to JQ. This is, and every one of these little ticks, just for configuration, right? If you copy the text file and put it into Microsoft, and then copy that back into source code management and do a push or somebody to do code review, and one of these ticks like this one, which I put there on purpose, that causes the whole thing to not work. Yeah. Good stuff, right? So we got JSON too, and that's just for console, let alone all the systemd configuration stuff to go stand all these things up. So what's the alternative route, right? So there's really, we'll talk about Docker Data Center and Docker Swarm 1.12 here, but two other options, right? You might be saying, well, what about this Mesos or Mesosphere, right? That's another scheduler, another container orchestration tool, or Kubernetes. Who's heard of Kubernetes? Handful of hands. Pivotal Cloud Foundry. I know we had that one. So they run containers as well. Red Hat OpenShift. No? OK. Which is Kubernetes underneath the hood. Not used to. Until version 3, it was their own tools, but now it's Kubernetes. They do all similar things, right? But the key piece to remember about those tools, about Mesos or Mesosphere, the commercial distribution of Mesos, and Marathon, in Kubernetes, is you still have to do a lot of the same things that we just talked about. So instead of running console in Kubernetes, you run etcd. Etcd is a KV store. You got to run that. You got to manage it. You have to treat it like a distributed service that it is. If you're using Mesosphere or Mesos and Marathon, you're going to be using Zookeeper. Zookeeper, if you want to look it up, it's an Apache project. It requires the same care and feeding. It's not something simple to run. You have to throw an admin at it the whole time, just to run containers. So what do we do with today with Docker Swarm mode? So today we don't have to run all these extra services, with some exceptions. So if you want to run a special service discovery, you want to create your own universal service bus, you can do that. You just would get console and you can run that, or if you wanted to run etcd or some of the other services, you can. But by and large, just to run a container, you don't have to do that. You don't have to set up a CA and manage certs anymore. So that's done with Docker 1.12, that's done for you. Not only is it done once, they're auto-regenerated and they're exchanged. So we're not just using one key and keeping it there, we're actually using a key and we're rotating those keys automatically, or certs. You don't have to worry about DNS, that's baked into the engine. And it was before 1.12, but now it makes sense because they're clustering the entire thing together and offering services amongst all the different nodes. And there's this now concept of what they call services that are built into the engine itself. But you don't need to use that KV store. That's part of the engine. And we don't have to worry about tuning things like Raft or ZAB with Zookeeper, Zookeeper Atomic Broadcast. These are all protocols and things that you need to worry about tuning if you're going to run your own KV store. And you don't have to worry about proxies and their configuration and reconfiguration. So now this is that HA proxy piece. This automatically happens because there's an event bus that's built into the engine. So how do we set this up today? It really comes down to 2 commands. Now you got to run these commands multiple times because you're running it on nodes. So if you have 3 nodes, you've got 6 of these if both of them are managers. But we're doing an init, and we only have to know of our own IP address. In this case, because we're the manager. And then we do a join. And we just grab a token that we can get from querying any of the Docker tools, if you want to use the Docker tools, or you can write some scripts and use things like Puppet, Chef, and Ansible. But this is it. That's all that. That's it. That's all you need to do. So I was going to do a demo. I don't have time for that, but if you have any questions, that's all I have. I can be reached. I do a fair bit of blogging when I have time at NEBULAWORKS.com. I'm at Chris Ciborowski on Twitter. I'm always looking for a new fan to follow. So if you guys write some stuff, I'm always interested in looking at it. And company can be found at NEBULAWORKS.
Questions?
No questions. Nothing. All right, there's one.
Are you more of a fan of Swarm or Kubernetes?
Am I more of a fan of Swarm or Kubernetes? I like the direction that Kubernetes is going in the long term. And what I mean by long term, that's 5 years out. And the reason is they're already talking about some things that are innovative, are customers that are innovating need, which is federated control planes. That's something they already have a roadmap for. Does it work today? Kubernetes is what we kind of refer to it as. No, it doesn't. But the reality is that for 80% of the market, Swarm will work absolutely fine. Because the point is let's get to running containers, and then if you get to the point where you need to iterate and change out something, you don't have to worry about the technical debt. We're not changing little pieces of Swarm. You're just going to replace Swarm with something else potentially. At that point, yep.
Chris, there was a lot of talk in the press about different companies wanting to fork Docker because of the stability issues that you were talking about. Where are we at with that?
Okay, so from a stability perspective, that's not necessarily what we saw. The fork coming from the talk of forking coming from the fact that that there are a handful of vendors that don't like the pace of innovation that Docker has. So putting some of these tool sets inside of the Docker engine, specifically the KV store, and that's the big piece of it, and adding overlay networking, which we didn't talk about, but the ability to spin up networks, libnet, libkv, all of these pieces inside of Docker, that causes frustration to certain vendors because they're building their products based on the Docker engine as it was 2 iterations ago. So like Mesos, they only support up to Docker engine version 1.11, and Google is using 1.9, I think, on some of their tools. So that's where the frustration comes from. My take on it is, I think it's much ado about nothing. I think you start looking at some of the standards, OCI versus CNI, and decide what you want to do. Let the manufacturers build the plumbing to handle containers on their own. If they want to go a different direction, why fork it? Let the customer decide.
So you agree with don't fork Docker, please?
No, don't fork Docker. Because the tools run C, and guys, there's a lot of things that are kind of underneath the covers you can read about. Run C, which came from libcontainer, but all of this stuff has been open source, and the bones of running containers are in the Linux kernel anyway. So I wholeheartedly believe do not fork it. I don't think it needs to be.
Okay, good. Thank you.
All right, thanks everyone.